Hey guys, and welcome back to another GCSE Maths grade 9 exam style question. So for this question here, we're dealing with proofs. So the first part here, n is a positive integer. Explain why 2n plus 1 is an odd number for all values of n. So you've got to understand the idea of what's going on here. So we've got this n, it's just a positive integer. So remember, an integer is just a whole number. And we have to explain why 2n plus 1 is an odd number for all values of n. So it doesn't matter what value of n you put in here, it'll always be odd. So for example, if I put n is 5 in here, 2 times 5 is 10, plus 1 is 11. 11 is odd, right? If I put 3 in here as n, 2 times 3 gives me 6, plus 1, 7. So it doesn't matter if you put an odd or even n value in here, it's always going to come out odd. So you've got to think about why that happens. And the reason is, if n is just a positive integer, what is 2n? So 2n, well, 2n is just in the 2 times table. That's just your 2 times table, right? Algebraically. If n is 3, 2 times 3. If n is 10, 2 times 10. So 2n is always going to be even. Every multiple of 2 is even. So 2n is even. Always even. So therefore, when you add an odd number to this, it's going to come out odd, right? Even plus odd is odd, sorry. That's why this works. So even plus odd gives us an odd number. And obviously 1 is an odd number, so that's why that works. So that's that part done. And that's basically the general idea. You've got to explain why that concept works. And then for part B, we have to show using algebra that the sum of any 4 consecutive odd numbers is always a multiple of 8. So to give you a clue here, this is your first odd number, 2n plus 1. So that's 2n plus 1. So what's my next odd number going to be? Well, if I put 2n plus 2 in, that's an even number. So think about it, this would be 1. For example, my next number might be 2, and then 3 will come after it. So 3 will be 2n plus 3, right? The next one after that, hopefully you're getting the pattern, it's going to be 2n plus 5. And then finally, my last one is going to be 2n plus 7. So we need to add all these up together now, right? So 2n plus 2n plus 2n plus 2n, well, that gives me 8n. So summing these up, so add all these. So if we add all these, what do we get? So that's going to give me 8n. And now I've got 1 plus 3, so 4 plus 5 is 9, plus 7 is 16. So I get left with 8n plus 16. And from here now, how does this show that it's a multiple of 8? Well, if I can factor out an 8 from here, then it has to be a multiple of 8. So therefore, can we factor an 8 out? Of course we can. We've got 8n plus 16. So factor the 8 out. So that gives me 8 on the outside. And then inside my bracket, I'm going to have n plus 2. And that's it. We've shown that it's a multiple of 8 by factoring out the 8 from the expression. 8n plus 16. Factor the 8 out, we get 8 lots of n plus 2. And that's it, job done.